Hello guys, and welcome to my channel. So today we are going to solve a differential equation. So this is actually an ordinary differential equation given by x dy dx equivalent to minus 2y plus 3x squared. So how are we going to solve this kind of differential equation? So it is very easy. So there is techniques called integration techniques. Integration factor techniques, whereby we can solve it whenever we have a differential equation in the form of what? In the form of dy, okay, dy over dx, okay, plus px, p of x, y equivalent to q of x. So let's check if our question obeys this kind of form. So I think it is, because when we divide both sides by x, okay, and then we bring this to the left hand side, we will get this kind of form, right? So I hope you can see it. So let's divide both sides by x. So you will see, divide both sides by x, we just left with dy over dx, and then I bring the 2y to the left hand, minus 2y to the left hand side. So it is 2y, and then we divide by x, right? But I will make it like this, okay? 2 over x times y equals to 3x squared divided by x is just 3x, like that. Okay, so if you can see, basically our px is basically the 2 over x, and then so this is our px, okay, and then this one is our qx, right? So yes, we can solve it using the integration factor techniques. Okay, so the solution for this, I hope you already know it. Okay, the solution is basically d over dx times the integration factor times the y equivalent to qx times the integration factor. So if is basically refers to integration factor, and we know that the integration factor if is equivalent to e to the power of integration p of x dx, right? So the integration factor for our question over here is basically let me evaluate it first. Integration factor for this case is e to the power of integration px. So px in our question is 2 over x, so it is 2 times 1 over x. I do it like that, and then the integration of 1 over x is just ln x. It is actually 2 times ln x, but I bring the 2 as the raised to the x square, right, like this. So it is the same thing, and then I just ignore the plus c for the moment because it is just a constant, right? And this is evaluated to be x square. So this is our integration factor, and then using the solution, okay, for the integration factor techniques, so we will have d over dx in bracket, integration factor is just x square times the y equivalent to qx. So our q of x is just 3x, and then just times with the integration factor, which is x squared. So it is very easy. So I will bring this the x to the right hand side like that, and then we can proceed to integrate both sides. So the integration and then the derivative will cancel, right? So we just left with x square y equivalent to integration of 3x times x squared. So this is basically 3x to the third power, which is 3 x to the 3 plus 1, which is 4, divided by 3 plus 1, which is 4. Don't forget the plus c, constant. Or maybe, yeah, plus c, it's okay. Plus a, plus b, or anything as long as it is constant. And then I wrote over here, c is the constant. Right? So I hope you already know that. And then we need, as we want to solve the differential equation, it is actually to have, or to have the value of y, right, equivalent to what, right? So we make y as a subject. Over here we divide both sides by x squared, right? So we divide both sides by x squared over x squared. So x squared cancels, leave us with y equivalent to 3x to the 4th times divided by x squared, which is x squared there. So 3 over 4x squared plus I can make it like this, c times x to the power of minus 2, the same thing, right? So this is our solution for the differential equation. Okay, and I think that's all for me. So I hope this very brief and simple video can help you to figure out this kind of ordinary differential equation, right? So yeah, it's our answer, and thank you for watching, and goodbye, right?